I've asked my students to do some reading on the topic of classification of matter before they come to their one-on-one tutorials. Here's Ozzy now. Well, Ozzy, any questions about what you've been reading about? Morning, Prof Bob. Well, yeah, I do have a question. What's the point of learning all this stuff about classification of matter? Seems pretty academic to me. Well, classification helps us to talk about patterns of behaviour, be it people, plants, animals, ways of thinking, whatever, rather than have to talk about the behaviour or the characteristics of every single subject of the population we're talking about. So in classification, we assign things notionally into different classes of something or other according to some characteristic they have in common. For example, if we wanted to discuss some aspects of behaviour of TV watching, or of eating habits, or of the number of children they have, or how much money they earn, and how they spend that money, we could talk about the behaviour of Kevin and Judith and Raoul and Fatima and Benita and every single one of 7 billion people on Earth. But if we classify them into groups, it allows us to make a less complex discussion of patterns. And it also helps us to identify members of populations in certain instances. So, for example, the police issue a lookout notice for someone they suspect of a serious crime. And they'd look out for a man aged between 35 and 40, black hair, wears red spectacles and has got one leg, just the left one. Now, in principle, classification could work like this. Get all the people that could possibly be involved, and that might mean all the people in the country or all the people in the world or all the people in this town. Get them all together, this is if we did it physically, and say, okay, all of you people who are in the class that we call men, step forward. We've reduced the number of people we're thinking about. Now, all of you in the class called men that are in the class of age between 35 and 40, you step forward. And only some of them will. And now, all of you who are in the subclass of men aged 35 to 40, who are also in the subclass of black hair, step forward. And then of those, all of you who wear red spectacles, step forward. And now, of you, those in the subclass of people with one leg, that is the left leg, please step forward. And now we've reduced the possible identity of people that we might be looking for. We'd have a limited number of suspects. Fine, but we wouldn't have to do that in the same sequence that you did it. There'd be alternative sequences of class, subclass, subclass, and so on, wouldn't there? Couldn't there? Absolutely. We could first of all ask those in the class aged 35 to 40 to step forward. Then of those a subclass that wear red spectacles. Then of those a subclass that have one leg, left one. And then of those a subclass, I forget what, and then of those subclass that are men. Sure, we could do it that way. You're right. But it would make sense if the first category that we called out were those with just one leg, left leg. That'd be a very tiny percentage of our population, very likely, and the rest of the people could go back to work and we'd zero in more quickly, wouldn't we? Yes, good thinking. But of course nowadays we'd put all the classes, the classifications, into a computer database, press the button and it would look for them simultaneously. But I did it step by step by step, physically, just to point out the principles of classification. Okay? What's up, Ozzy? Well, I thought I was coming here for a chemistry tutorial. Well, you're right. Let's transfer what we've been talking about, classification in general, to the specific field of chemistry. And remember that classifications are designed, chosen by human beings. People don't automatically belong to classes. We choose the dividing lines between classes. And in chemistry, in introductory chemistry particularly, it's very common to talk about a classification of matter. What does that mean? Any material, or as I call them, any stuff. We can classify stuffs. And in introductory chemistry, it's very common to talk about, by example, classifications that involve these 6 concepts: elements, compounds, pure substances, mixtures, homogeneous and heterogeneous. Now, we could do what we were talking about before in identifying a police suspect. We could talk about matter can either be the stuff we're talking about, can either be a pure substance or one of the class of substances called mixtures. It's a pure substance. It can be one of the subclass called elements or subclass called compounds. And if they're mixtures, they can be in that subclass called homogeneous, and we give them a name, solutions, or heterogeneous, and we give them a name, suspensions, or if they're solid mixtures, aggregates. Okay? That's one way of going through things. And the other is, we could say, stuffs can be either heterogeneous or homogeneous. And if they're heterogeneous, they are suspensions or aggregates. If they're homogeneous, then those stuffs are either pure substances or mixtures. And the pure substances can belong to our subclass of elements or subclass of compounds. And if they're homogeneous and they're mixtures, we call those things solutions. Now, in this particular case, it's not so much about identifying, but as using this to clarify relationships and to clarify meanings. I haven't gone deeply into meanings, but this would be a useful way of sorting out the meanings of some of these concepts. Okay, all this stuff about classes, subclasses, subclasses, and membership of classes and subclasses reminds me of something we did somewhere else about that used Venn diagrams. Is that applicable here? Oh yes, it is indeed. In fact, coincidentally, I've arranged into a Venn diagram the relationships between those 6 concepts. So I can put all stuffs are somewhere in this square. Some of them from there to there are pure substances, some are mixtures. Some of them, different dividing line, are homogeneous, some are heterogeneous. The pure substances, homogeneous, can be elements or compounds. Mixtures which are homogeneous are solutions. Mixtures which are heterogeneous are suspensions or solid aggregates. That's a neat way of expressing what's what and the relationships between them. Good. So we could also use this to identify a substance, a material, if we know which class of material it is that we're talking about, just like with a police suspect. Well, we could, but this is a limited number of defining characteristics here, so it's got limited ability in being able to distinguish one thing from another to identify them. But if, for example, we talked about chlorine gas, sodium nitrate, solid, sodium nitrate solution, and mud. And there were the four suspects, and we knew that it was a homogeneous mixture. Then homogeneous mixture must be a solution, and it would be this one. And if it was a heterogeneous mixture, it would be mud, and so on. So the Venn diagram is useful to a degree there. It's mainly for purposes of clarifying meanings of these terms. But if we really wanted to identify something, we'd go to classifications that involve much more obvious characteristics. So, for example, is our stuff a solid, is it a liquid, or is it a gas at a defined pressure and temperature? Dividing lines between things are very often fuzzy. So we say solid, liquid, gas. We need to qualify what temperature, what pressure, because things change. Their form changes between solid, liquid and gas if we change the pressure and temperature. We might say, well, what about the colour of this stuff? Is it red? Is it green? Is it yellow? Is it colourless? And there are many, many other defining characteristics, of which you could think of some, I'm sure. I'm sure I could, Prof. Now that I think about it, and I think about chapter headings and subheadings, hundreds are coming into view. Is our stuff soluble in water or insoluble in water? Is it, if it's a compound, is it an inorganic compound or an organic compound? And I know you keep telling us that the dividing line between those is very fuzzy. We could talk about, is it an oxidizing agent or a reducing agent, or neither? Is it an acid, a base, or neutral? And a whole pile of things. Yeah. Good. And is our stuff in the class of things that we call group 1 elements of the periodic table, or group 2 elements of the periodic table, to group 18 elements of the periodic table? Is our stuff an electrical conductor or a non-conductor? There are many, many defining characteristics that decide which side of a line, a fuzzy line, we put things in. Two important things there. We decide on classification. Things don't belong, aren't born into a classification. We decide, and we can shift those lines. And the lines can be fuzzy, as I keep on impressing. One of the most obvious ways of fuzziness of lines is distinction of classification into metals, non-metals, and intermediate semi-metals or metalloids. Just depends upon the characteristic properties upon which you're defining something to be a metal or a non-metal or in between. So different people using different characteristics come up with different lists of what are the metals, what are the non-metals, what are the semi-metals. So good. It's a good discussion, Aussie, even if it was a bit broader than chemistry. Good. Good. Thanks, Prof. Bob. I am going off to hang out with a class of people to whom I've given the label my friends. Okay. Good. And I will shortly have a tutorial with a member of the class of people who are university students, subclass of people who are university students in this university, and subclass of people who are enrolled in this chemistry course, 1003. And Prof, I believe that there are 3 members of the class labelled my friends who are also members in common with your subclass of people enrolled in chemistry 1003. This could go on forever, Aussie. On your way.